Hi, you're welcome to Explore Insights. In this video, I'd like to talk about binary coded decimal. Now, what is binary coded decimal? Binary coded decimal, also called BCD, is considered to be a number system of 9 where each and every digit is represented or corresponds to a 4 bits. Now we will proceed with the BCD addition. But like I said, every digit will be considered as 4 bits. So let's take a look at this example 1. We are asked to find the BCD of 38. Now, what are we going to do? The first thing we are going to do is to obey the rules, which says take each digit as 4 bits. Now, when we consider 4 bits, it will be in the um, position of 2 raised to power n, where n represents the bits. So in that way, we will go with the place values where we'll have 2 raised to power 0 represented as 1, 2 raised to power 1 represented as 2, 2 raised to power 2 represented as 4, and 2 raised to power 3 as represented as 8. So this forms our 4-digit bit display. Now, if we are to consider the BCD of 38, we are going to consider each of these digits. What do I mean? It means I'm going to take 3 and locate what value it's going to give us here. So in this scenario, 2 plus 1 will make up 3. So I'm going to turn that on, representing it as 1. So this is why we have 1, 1. Whereas for 4 and 8 will be zeros. Now for 8, what will make up 8? It's going to be 8 since we have 8 here. So we'll have 1, while others, which then sum up to make up 8, will be zeros. So that is to say, if I are to consider the BCD of 38, we are going to have 0011, which this represents 3, 1000, which this represents 8. So at the end of the day, our answer will be 0011, 1000. So recall, when we talk about BCD, it's different from binary. So let's consider a scenario if the question were to be asked to find the value of 38 in binary. Now, this is how our binary value will be represented. First, if we are to locate 38, the same way, I will consider how many bits will represent 38. And with that, I'm spreading out this values, which ranges from 1 to 32, gotten from the value of 2 raised to power 0 to 2 raised to power 5. Now, with that, you can simply tell that the number of bits that should represent 38 will be 6 bits. How do I know? 1, 2, 3, 4, 5, 6. That is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. We're simplified to this format. Now, for me to get 38, I'm going to consider what we sum up to give me 38. And you can see that if we take 32 from 38, we are going to have a remainder of 6. So it means I can turn this by representing it as 1. Now I have to consider values that will sum up to give us 6. And with that, I'm going to sum up 4 and 2. So with that, I'm turning that on. Now, if we are to consider the binary of 38, the answer will be 100110. Now, don't be confused when we talk about BCD of 38 and binary of 38. So to conclude with this, I would like to tell you that the BCD of 38 is 00111000, whereas the binary of 38 is 100110. Please do not confuse this whenever you are asked question like this. So let's go over to what we have today, which is the BCD addition. Now, when we talk about BCD addition, it means we want to sum up two or more digits. So let's consider where we are asked to find the BCD addition of BCD 8 and BCD 7. Now, like we say, we are going to represent each digit as 4 bits. The 4 bits are being represented as 8, 4, 2, 1. Now, for 8, what will sum up to give us in that 4 bits? It means we are going to have 1000. Why? Because when we talk about 4 bits, we literally have this 8, 4, 2, 1. So the 8 here will be turned on as 1, as we have likely seen above in the example 1. Now, if we consider BCD for 7, we are going to have 0111. Why? Because this represents 1, 2, 4. So 4 plus 2 plus 1 will give us 7. Now remember, we are not asked to just write the value for 8 and 7 of each BCD. We are asked to sum them up. So for us to sum up, we are going to add 1000 plus 0111. Now go along with me. Let's do the summation. So 0 plus 1 will be 1. 0 plus 1 will be 1. 0 plus 1 will be 1. 1 plus 0 will be 1. So at the end of the day, if we want to sum BCD 8 and BCD 7, we are going to have 1111. Now, we have to consider something, which is another rule guiding BCD, because there are two statements in considering BCD. One is to check out if BCD is valid or invalid. And together we said, if x is greater than 9, we said that the BCD is invalid. Whereas if x is less than 9, we call it valid BCD. But how do we know if the BCD is greater or less than 9? Now let me take you through. The same way, I'm going to spread out the bits, the 4 bit representation. So now, if we have 1111, it means that every bit, the 4 bits were turned on, which gave us 8 plus 4 plus 2 plus 1. And the summation of this will give us 15. Now, go on with your comparison, which we are going to compare the value 15 and 9. So you can tell that x is greater than 9. That means 15 is greater than 9. Since 15 is greater than 9, it becomes invalid. Now, in a situation where we have invalid BCD, what are we going to do? We are only going to add 6. And in 6, the binary form of 6 is 0110. So to that, for us to correct this invalid BCD, we are going to add 6. So if the summation is greater than 9, then it is invalid BCD, which I've said. So we want to make it a valid BCD. So I'm going to bring out this result down here and add 6. Like I said, the 6 is 0110. Now, what are we going to get? So let's go on with the summation. So we have 1 plus 0, 1. 1 plus 1 will be 0 carry 1. Remember, the carry is represented with a blue ink. And then we proceed with 1 plus 1 plus 1 will be 1 carry 1. 1 plus 1 plus 0 will be 0 carry 1. And here we will have a carry 1. So we can see that from here we have 10101. Now, what remains? Remember, we have to represent it as 4 bits. Now, if we take from right to left, we are going to have this as the 4-bit representation. And from here, we only have 1. So the next thing we need to do is to go on with our padding. So our padding will be a value of zeros, which has no significance at this part. So we are going to have 1000 here. Now, sum that, we are going to check, putting on the 4-bit 8421, what exactly we turned on as 1 was 4, and 1. So 4 plus 1 will give us 5. Whereas here, which is 8421, this is 1, so it will be 1. So at the end of the day, we are going to have 15. That is 1, 5. So this literally tells us that 8 plus 7 in decimal form gives us 15. But when we are to talk about the BCD, you should take note that it will be 10101. But when we are to talk about the binary addition, it will be 1111. So don't be confused. Maybe you are faced with this kind of question. Please do not leave your value this way, because this is invalid BCD. The rule states that whatever value you have should not be greater than 9. So if it is greater than 9, do well to add 6. And when you add 6, if the value doesn't make up to 4 or 8 bits, which is 4, 4, do well to add 0 paddings. So I hope you've been able to grab the knowledge from this topic. Remember, I talked about binary coded decimal, and I went further to talk about the binary coded decimal addition. If you have not subscribed to this channel, please do well to subscribe to this channel. I'll be signing off now. Do well to like and share with your loved ones. Bye.